Bismillah ar-Rahman Rahim. Today we'll discuss about the determination of soil texture. So we generally use Stokes law method, but that has some limitations as well, and there are also few assumptions. So we will talk about that. That what is Stokes law and what are the assumptions of that. Uh, we know that soil texture basically the relative proportion of sand, silt, and clay. And if we know the concentration or the percentage of sand, silt, and clay in a soil sample, so we can determine this texture class by using this triangle. We have already discussed in detail in the theory lecture. And we also know that the sand, silt, and clays, they are differentiated based on their size. The finest particle, they are clay, and then we have silt, and then we have sand. So it means that we have a clear differentiation of size for these three particles. And on the other way, we can also say that the mainly the texture is based on the size of different particles. To determine this, the percentage of sand, silt, and clay, uh, we need relative amount of sand, silt, and clay. It is determined through particle size analysis, and this because we know this, the difference is the size, and that size can be utilized as a parameter or as a what you say as an indicator to determine the soil texture class. For that, we know that the separate particles are to measure particle density at a certain depth in the suspension of soil and water requires knowledge about the settling rate of different size particles. So, the particle size analysis is basically done in a fluid and liquid, and for that we must know that how the particles they move in the fluid. For that, we need the particle density of the soil particles, and then of course the density of the fluid which we are using. Stokes law basically provides the basis for this type of analysis, and the law simply balances the downward force due to gravity with the resisting force due to Biochus. Uh, because we know that the force of gravity pull the soil particles downward, and at the same time, so there are also forces which are obstacling this movement. That is the surface of the particles and their connectivity with the fluid, the friction, and the solution movement. So all these are involved in that. According to Stokes' law, the movement of particles in a fluid depends on the viscosity of fluid, the fluid in which the particle will move, the radius of the soil particle, of course, the size of the soil particles, force of gravity, uh, we know that it's constant, and density of soil particles and fluid. And density, we know that that is mass over volume of that particles. So for that, we use this hydrometer to determine the distribution of the different kind of or different size soil particles in the fluid. So as I mentioned earlier, that Stokes law basically balances the forces. This is the force of gravity, which pull the particles downward, but there are also some forces which are restricting. So this law basically provide all those restrictions in a calculated form, that we have certain forces which are acting upon that, and they will slow down the movement of the particle, which we are considering that is according to the force of gravity. So for that, this B is the velocity of fall, I mean the rate of fall of that particle, which we will use in the fluid. Density of particles, of course, uh, that is milligram or megagram or gram per cubic meter. Density of the medium, the fluid which we are using, that has also some density. acceleration of particles, that is the force of gravity, that is constant, then radius of particles. So that is basically the parameter which we use uh, to determine the settling time, because that is dependent on the radius, and we have a different radius for different size Hall particles. So that will uh, differentiate the time of, or differentiate the settling time of the particles, and then the viscosity of the medium. So it means that if we want to analyze based on radius particle, all other should be constant. If they are not constant, so we will have to take some assumptions. Before going to that, I just want to differentiate the density and viscosity in a simple way. So density, as I mentioned, that is the weight over volume occupied by those particle or fluid, while the viscosity is a measurement of intermolecular forces and molecular shapes, molecule shapes. Viscosity tells you about the friction between two layers of the given fluid. Density varies slightly with the temperature, while viscosity changes rapidly. So as we have seen that the viscosity of medium is also important, it means uh, uh, we have to take care of temperature as well, because the temperature will have a definitely effect on the viscosity of the that fluid, and that will have uh, effect on the settling time of the salt particles. So, because we have to follow the Stokes law to analyze the soil texture, uh, the particles, so for that we have to make some assumption. The particles move at their terminal velocity as soon as settling starts. So because when we put the soil in the water and we start the stopwatch, so it means from the start the speed is the maximum. So generally it does not happen. Then we have a settling velocity must be so slow that no turbulence occurs. And now the velocity of the particles with which they are moving downwards, so that is so slow that they are not creating any turbulence. So if you have a sandy soil and you have more sand particles, of course they will not move very slowly. So there will be turbulence as well, but we assume that there is no turbulence. So there is no slipping between the soil particles and the liquid movement molecules. So between the soil particles, we can minimize by reducing the amount of soil particles in the fluid, or the relative proportion of sand and relative proportion of soil and the water in the in the in the glass jar, etc. But the slipping with the liquid molecules, so that cannot be managed even. But we assume that there is no such kind of issue. Then particle must be smooth and spherical. So generally they are also not very smooth and spherical. There are some smooth and spherical as well, but we assume that all are smooth and spherical. And then because they will also affect the movement. The extent of the liquid must be greater in comparison with the size of particles, so that we can manage that. We have a specific calculated amount of water, and then we have a very calculated amount of soil, so that there may not be hindrance. So we have also some limitations. That is also basically based on the assumption which we have made. Different shaped particles settle with different velocity. So this is the defect. If the shape is different, even the size is same, but the shape is different, so that the velocity will be different. Convection current arising due to difference in temperature near wall of the vessel and within the suspension may result in non-uniform settling of the particle. So it means if the temperature outside the jar and the inside the jar is same, then there will not be issue. But if it is like that, uh, then there must be issue that the temperature uh, along the vessel walls will be different than the in the in the center. Stirring may also result in convection currents, which are uh, difficult to eliminate than those caused by temperature variation. So when you are stirring solution or that suspension, so that will also have some current convections, and that can have some impact on the temperature and the movement as well. So that was all about today's. We will talk about the methods in the next class, but we have to understand it clearly for today. Thanks.